Hi everyone. So I've been playing around with a couple of cross-chain protocols recently. I've played with Layer Zero, I've played with Wormhole, and today I want to zoom in a bit on Wormhole. Before we move on, let's go very straight to the point. What is Wormhole all about? It's simply a protocol that facilitates communication of tokens, messages, and queries across different chains. And the reason I picked interest in diving into protocols is that as a smart contracts developer, on days when you need to build cross-chain applications, you should know the right infra to use and how to use that infra. And a side bonus to security researchers, you can't break the code you know nothing about. In this video, I'm going to be talking more about the native token transfer of Wormhole because that's what I found kind of more interesting. So with the native token transfer thing, you'll be able to create a token on chain A and be able to transfer it to chain B without any friction. Now let's go into how this works in detail. The first thing happens on the source chain. So as a user, you have to approve the burning of this token on the first chain. And once you do that, the Wormhole contract will pick it. The next stage is the off-chain stage, where the Wormhole guardian will try to see if everything in the transaction is done correctly. And once they approve it, it goes to the destination chain and you get back tokens in the chain you are trying to bridge to. All this leverage the Wormhole bridge under the hood, so you get the point. Now, on the dev side of things, they have two dev kits. The first one is the Entity Connect. The second one is the Wormhole SDK. So the Entity Connect is more for front-end developers who want to use Wormhole to create cross-chain token transfers. On the other hand, the Wormhole SDK is for we smart contract developers. Everything you need to build cross-chain tokens is already embedded in the Wormhole SDK. So it's just a one-up installation for you to pick up things and ship fast. Now, enough with all the talk. Let's get into the code and play around with an entity using the Wormhole SDK.
Of course, the best way to know about a protocol is to read their doc and get to know how it works. This is the same thing we'll be doing with Wormhole now, and this is their doc. We'll be reading and coding along how everything works, and you'll see it in real time. So the first thing to do is to install the Wormhole SDK. Write your VS Code and simply say this. Give it a couple of minutes. Our installation is complete now. So let's go into File and create CrossChainSender.sol. Check the doc and paste it here. Let me take a couple of minutes to explain what transpires in this code. So we imported the Wormhole SDK here, the relayer SDK that relays across chains. Then we got IRC20.sol. Then of course we inherited here and created the gas limit. But we have to pass a couple of parameters through the constructor, and the first one is the Wormhole relayer. That's the address of the relayer for Wormhole. Then you have to pass an address of the token bridge in question. Then you have to pass the actual Wormhole address. So the first function is quotes. Give me a minute. Quotes cross-chain deposits. As you can see here, this is the function to get the estimated cost for cross-chain deposits. The main purpose of this function is to know how much the estimated cost for the deposit we are about to make. Of course, you pass this argument of the target chain. Then we expect it to return function, which is a unit variable to return costs. And here you define your function, the gas limit, then you define that costs is assigned to delivery cost plus wormhole or message fee. You might wonder that delivery cost and wormhole or message fee are not declared at the state of this contract. You are very correct. If you check the wormhole relayer SDK, these variables are there. Then this is the function that send tokens and payload across chain. This is the actual function that gets things done. Of course, you have to pass the target chain, receiver, target receiver, recipients, amount, and token. Make it payable so that it can receive Ether or receive any token in question. Then assign your cost, define it. For fluency, we have to create a require statement here that the value should be equal to, not assigned to, should be equal to the costs. If that condition is met, then we can use transfer form to transfer from MS0 to this address, and we are transferring this particular amount in question. Then we'll encode the recipient. Now we'll send the token with payload to the EVM along with these parameters. This is the cross-chain sending contract. You can name it anything, but this is the contract that makes us to be able to send anything across chain using the Wormhole Relayer SDK. Having done that, let's look into how to create a receiving contract for these sending contracts. Now go to the doc, copy it, paste it here. Of course, you should understand what you are copying, and that's why I'm going to take a couple of minutes to explain the code. Definitely, this is you importing things, inheriting it. Then we are passing. This is similar to the arguments we passed into our constructor in the CrossChainSender.sol contract. And mind you, the main essence of this contract is to be able to receive tokens, cross-chain tokens or multi-chain tokens. Then the wormhole relayer and the registered senders are inherited from the base.so contract, which is why I'll really encourage you to go read the actual core wormhole contract. Having a very good understanding of core wormhole contract will help you understand which contract to inherit at some points and how to really work around them. If you want me to go deeper into Wormhole and shoot more videos around core Wormhole contract, do let me know in the comments and I'll push out a couple of things on that. This is the contract that received the payload. Remember that in cross-chain token, in CrossChainSender.sol, we had a function for send cross-chain deposits where we have to deal with payload to the EVM. Now in the cross-chain receiver, this is where you receive it. You say what you want to receive, then make it an internal function. Put this require statements, then define your recipients. It should be the address from the payload. And for better security, it's better for you, since it's encoded in CrossChainSender.sol, you should decode it right in this function. When you've decoded it, you can make a transfer. And that simply solves it all. Let's try to compile this and see how it goes. Forge build. Let's see. Okay, give me a minute. Let's compile it again. Now you can see that the compilation passed. If you want to take this a step further, you can write a foundry test for some of these functions.